Hello, everyone, and thank you so much for having me here today. My name is Shalev. I'm a data scientist and a natural language processing researcher at Intuit AI's text and speech team. And today I'm going to talk about the key role natural language processing is playing in modernizing customer success operations. Intuit is a financial software company. It develops solutions that simplifies the business of life for small businesses, consumers, and accounting professionals. One thing that's in common for all of Intuit's customers is that when they need assistance with our products, they call customer success. And as you can see in the picture, the agents are happy, the customers are happy, because calling customer success is so much fun. Well, not really. We all are customers, and we all know that the waiting time can be super long, and that we can speak with an agent that is not knowledgeable enough, or we can find ourselves calling again with the same issue because the problem was not resolved in the first conversation. For these reasons, Intuit is putting a lot of effort in making its customer care services as efficient and as professional as possible. And the text and speech team I'm part of is responsible for developing machine learning tools for this purpose. The first way for Intuit to understand if its customers are satisfied by the service they received is by sending a questionnaire, like you see in this photo. The question here is based on this interaction. How likely are you to recommend QuickBooks to a friend, colleague, or a family member? This question is called TNPS. Remember this term because I'm going to mention it a lot in this talk. And the customer is asked to fill a number between 0 to 10 that will explain how satisfied he is from the service. And we all get those questionnaires after calling call centers, but how many of us really take the time to fill them? I know I don't. In fact, our data shows that for each questionnaire that only about 10% of the questionnaires that we send are getting responses. So what can we do about it? What we do about it is that we train a classifier that based on these 10% of responses that we do get, learns how to classify the rest of the 90%. And then by identifying dissatisfied customers, we can maybe be proactive about the service. As data scientists, our job is also to identify inefficiencies and to fix them. Intuit's call centers receive about 18 million calls per year. If we could reduce even just 1 minute from the average handle time of our conversations, this will be summed to a lot of money. So modernizing customer care saves money. Now we'll continue with the TNPS example, where we want to predict whether the customer is going to recommend or not to recommend our product to his friends or family. And what we have as data is the transcript of the conversation. But before we can try to predict, we need to define a way how to model a conversation. Now, one thing to note is that conversations are long. So when we explored ways to model a conversation, we explored existing methods for document representation. One of them is called Hierarchical Attention Networks for Document Classification. Next, I'm going to explain this method and to show how we extend it by adding domain knowledge to model a conversation. So one difference that we need to understand between conversation and a document is that while documents are comprised by sentences, a conversation is comprised by utterances. An utterance is a continuous piece of speech which is begin with and end with a clear pause. So an utterance can be as short as a single word like yes or no or thanks, and it can also be a very long sentence like thank you for calling QuickBooks, my name is Adi, how may I help you today? It can also be an incomplete sentence. For example, when one participant starts a sentence and the other participant interrupts in the middle of the sentence. And we get sentences like, yeah, but. So the first step of our model is to find a representation for utterances. And what we have here is that we take a word representation, and we feed a GRU layer, and on top of that, we have a attention mechanism. Now, a GRU is a type of RNN, recurrent neural network. We can consider its hidden state as a contextualized representation of words. And the idea behind the attention is that instead of throwing all those all those intermediate steps of the GRU, we want to use them to learn a representation for the utterance. Okay, so the part below is what we already seen, the word encoder and the word attention. And the part above is the utterance encoder and the utterance attention, where we actually take each utterance representation and feed it to a second GRU and a second attention layer. There's nothing really new here. We want to learn the contextualized representation of an utterance, and we want to be able to use all the intermediate states for modeling, for creating this context vector. And so far, at least in terms of the models, there is no change from hierarchical attention. We know that the data is slightly different because we talk about utterances and not sentences, but the model architecture is exactly the same. So next I'm going to add some domain knowledge, the features that we have in conversations, but we don't have usually in documents, to this model. I just removed the word encoder and the word attention because they are not changed at all. And here we use the utterance encoder as I presented before, and we had two new features. The first one is participant embedding. This feature is for us to understand who said this utterance. Because when someone says, yes, thank you, you really helped me, it really matters if the one that said it is the customer or the agent. And also, four more features actually, that we add is the utterance positions in milliseconds. We have 4 timestamps, the begin and end time of the utterance relative to the beginning of the conversation, and the begin and end utterance time relative to the end of the conversation. Because if we have 2 sentences like, oh yes, I'm definitely going to recommend this product, or sentence like, oh no, I'm definitely not going to recommend this product, then we want to know that the positive one was the last one that was said. And here we can see some results when we train our model with the TNPS data. We first simplified it to include only strongly recommendations or strongly unrecommendations. We took only 0s and 10s, and we tried to distinguish between negative and positive examples. And our model gets a ROC area under the curve of 0.88, which means that it is able to distinguish between positive and negative examples with high probability. Summary. So we saw that natural language processing is useful for call center service efficiency. And we saw one way to do that through TNPS prediction. And we also saw that conversation modeling can be seen as document modeling together with some domain knowledge. And we saw one model that represents this to represent a conversation and a document. And we saw some results. And what I think that I want you to take from here, that if you ever somehow work with conversational data, then think about it as document and then try to add your own features from your domain. Thank you.